I'm. By the way, I'm here in an office. So.
Oh, okay. All right. Well, let me just tell you kind of what happened. I was talking. I've been working on a large language model integration with the VS Code extension for ECL. So I've learned a lot about large language models recently, and so I've actually used one with LangChain to read in a document, the ECL document PDF file, to then query it all locally using Llama LLMs. And while in the meantime, I was understanding more and more about how large language models work. They're really they're really text vectors, really. I think that's where kind of everything started. I mean, the language, and then of course the transforms and all that thing were added to it. But so the text vectors, and then we were talking about I can't even remember anymore. There's so many things that have happened. So basically, I ended up talking with Roger Dev. Roger Dev is a little older than me. He's in his late 60s. He's a guy in machine learning and neural networks for a long time, old school guy. He and I always got along because we were, the hype is greater than the reality. And it seems like a lot of people we're talking to these days seems to see that. And so we were talking about something Amnon and I have talked for a long time. Amnon's had ideas about this, so I'm sure he'll argue on stuff. But when we were talking, there was a couple things that hit me like a ton of bricks. One of them was Roger doesn't work in machine learning right now, but he's not so having to sell it so much, because he was in a position of having to stand up in front of audiences and say text vectors are meaning. Of course they aren't, but that's because he was reporting on what he was integrating into the HPC systems group. Now he's more free to kind of talk more frankly about stuff. And the thing that he told me was kind of shocking, because we were talking about, the large language models. I just like to talk with him once in a while, kind of at a high level, philosophical AI. Two guys in their 60s, been through all the AI over the decades. And he said this sentence. He goes, well, it's obvious the main system has to be rule-based for AI. And I was floored by it. Huh?
It's obvious?
That's what he said from his work. Meaning he has worked in it long enough to understand the limitations. It is, in the end, even as much as they're doing the ChatGPT 4.0, which now has a one neural network for text, video, text, graphics, video, and audio. It's still guess. It's still a guess, a statistical guess on all that side. So
we just lucked into the right slot.
Yeah.
All these decades, yeah.
Yeah, probably. But what's interesting, one of the things is, and you put this in perspective, let me give you another conversation I had. One of the people we hired to do the Python package for NLP++, which was submitted in January, and because Python's so ridiculous, it's not approved still. It can take 9 months. When he was a computational linguist in his at least late 50s. And he said, this is the way it works. In the beginning, of course, you had the NLP systems were rule-based. They then integrated in the 2000s, they integrated the machine learning, neural networks, and then they used rule systems that they had still around to try to correct the problems coming out, the kind of illogical problems coming out, but try to classify any ones they find to fix it in the end. So he says that's the way it would work. So if you're looking at the integration between rule-based systems and statistical systems, you can think to yourself, well, statistical systems can use rule-based systems, or the older system, rule-based, statistical rule-based. Okay, that's already there. Or you would do, Amnon and I've talked about this, he a lot as well, is you can take statistical systems and use them in NLP++. Now, the first one being a guy who's been in machine learning for a very long time, saying that it's going to have to be rule-based. And I think what he means by that, Amy, is that to do things that are trustworthy to do things that are in these places that people want to do these things, you have to have traceability. You have to have that confidence. And I think that's what he means. We're not talking about assistants like we have now, whereas type something in Google, Google will give you the large language model response. Or you type something in Copilot and you read, Copilot is your Copilot. He can get things wrong. Check things. That's why they name it Copilot everywhere. I mean, right now they're integrating Copilot everywhere. And so, but they are always caveating at that. So that's, I think, what he meant by that statement. The other thing that kind of hit me like a ton of bricks, because then we started talking about, well, what can you query in a large language model that would help solve some of the problems you're going to come across in LP++. And, he was saying things, well, what if you don't know a word? And could you ask a large language model, what's the probability of Alice being of a name, or Alice being a name of a street or a city? So he started querying things. He queried, what's information. You go into a large language model and you can just ask it questions. So when we were doing that, it kind of finally hit me what could go on here. And that is, when you build a system with NLP++, you build a system from a person building it using their brain, and you instead of training systems, you use a programmer's brain to generalize, right? And you're not going to make a obituary parser that's only going to work for that one obituary. You're thinking generalities, and that's why you can use a small set of stuff and still produce a robust parser. Well, what happens in that scenario? You build it, you put it out there. A lot of times in the NLP++ code, you'll shoot stuff out that's not working. What do? It goes back to the programmer. He looks at those, generalizes some more, adds it, and improves the parser. Now, what hit me like a ton of bricks was large language models have text input and text output. And NLP++ can look at that in a very kind of intelligent way, meaning, so what do? Instead of me programming let's say, Guilherme in our company right now is finishing up in his talk, is going to give a talk at our conference about his simpler address processing using NLP++. Now, there are times where he doesn't know where something is. So what does he do? He goes out into Google and goes out there and tries to find it. Or he goes out and tries to find information. Now, if you have this all-knowing, or even certain things, I'll give you an example. One of the large language models, one of the things people are using large language models for with these agents is one that goes out in the internet, and you can query some pages using the large language models. How does a large language model do all that? Well, it just takes the query, puts it into a text vector with all the relationships, with the text vector in the relationships of the large language model, has that matching going on, and then gives you something back. What I was thinking was, this is a perfect situation. What you can do is you can rewrite or write into your NLP++ parser something that says, I don't know what this word is. Here's how I know what this word maybe could be. Send it out to a large language model with the right question. Get the information back. Have that augment your dictionary and or knowledge base, and eventually even kinds of phrases. And so that you would end up having it, and this is farther into the future, folks. This is just the first idea. This is not, but the idea would be is, instead of having the human being have to come back to the rule-based, knowledge-based system, you now have something that we didn't have before, which was a natural language query system into general knowledge, with a natural language system that you can bring back and even tell it how to format stuff, right? You can even bring it back in a way that you can say, give it to me in a JSON file, right? And so what you end up doing is you augment the way that two things have to happen. NLP++ should be able to use large language models, and you would write your NLP++ code so that you can augment it. So the guy who's writing it for Brazil, he and I went on many journeys with email, with addresses in Brazil that didn't know what was going on. So he would go out to these certain places and he would query certain things. Now that's interesting and that's not easy to do. But now if you have the large language models, all of a sudden you have almost like a person there who you can query like a librarian about almost anything. And that querying of like a librarian will then replace you going through and augmenting things that aren't there. So your system becomes much more robust, and it, it builds itself. Now, of course, Amnod's conceptual agent, this whole thing where you build this kind of NLP++ conceptual agent functions or whatever class, whatever, that goes out and starts building things on its own. Yeah, you can do that. So it's interesting because what it means is you have a rule-based system tapping into, these general knowledge systems, or even specific knowledge systems, or even web pages, or even Wikipedia, which they also do, and be able to, in a specific task, say, I'm now not only going to do the task of understanding the text, I'm going to I'm going to code into the task the ability to augment the system the way a person was. And you didn't have that before at all. And the thing that why is it now? Why is it before or not before? It's because it's all language. And NLP++ in that sense is the king of processing language the way kind of people do. As a computer language, a rule-based, knowledge-based system. So what does this mean? It means that we should look into how we augment NLP++ to be able to tap into large language models, to be able to say, okay, Guilherme, give me the simplest case where we don't know what this word is, but we want to add it either to boroughs, or we want to add it to the cities, we want to add it to a street name. Saints, they have more saints in Brazil than you can shake a stick at. And I have I don't know if we have that there, but you could have it so that if you see saint and a word you don't know, you add it to the saint dictionary. And you can go out and check it. You can even go out and check it, get some information, and even spit it out. The thing about that is also, which is really amazing, is you have traceability. You are giving some traceability to large language models, because what you have is you have it going out, NLP++ going out for a specific task, going and asking the question. You can say where you asked that question. You can say the answer you got back. So if something goes wrong, you can say, well, I went out there. Our system went out there, got this general information. It got it from here. That's what it thought. That's what went wrong. So you're even though that's not directly telling you why that place got it wrong, you are basically having a system now, a rule-based system using statistical information. And now that's the only thing you can do, obviously. And Amnon's talked about this a long time. Again, the difference is large language models are only a couple years old in public wise, and those things are text-based. The other thing that's amazing about it is we think things are intelligent because we can say in words, make this picture, and it makes that picture for us. We can say in words, make this music. This is one of the things in my Clemson, the lecture I gave at Clemson was knowledge, human knowledge and language are together. We judge intelligence by the use of language, even when we're talking about creating a music, or even any of those things. So that's, I think, kind of Roger Dev, his own conclusion. That's his opinion, that rule-based systems should be the nucleus of things that are are systems that will be in place to replace human readers, which we have confidence in, so we can see that. And large language models are like having that person there doing the research to augment whatever you're doing. And of course, the sky's the limit with this. And we're not just talking about adding the dictionaries. You could build, you can have a system that all it does is go and build these knowledge bases in medical, all those kinds of things by doing queries to get that information. And not only that, with the rule-based system, you end up having, in that rule-based system, you have the statistical stuff is there, but you have a trace of it and how you used it. So if you tell somebody that I went out to this website, you went out and got the information, you get back the website, you keep that in your database of what you've done, something goes wrong, someone sues you, you come back and say, look, yeah, this is what happened. This is what we did. This is the place we got it. And so, yeah, it turns out that's not what they can go. Okay, I get it. Whereas if you just go to the generative stuff, get the answer back from them, you have nothing there to fall back on. So that's it. That's all I came up with. I think it's pretty amazing because one, people don't know really about NLP++. They still don't. And number two, having a person in machine learning say, yeah, for these real world, how do you say, critical systems, you need to have rules and rule bases. So I'm sure Amnon has his own thoughts on, it's not a big deal. Again, the big deal to me are those two things.
I'm not saying it's not a big deal, but so you're getting language from LLMs. For one thing, the more complex that piece of knowledge, the more you need to analyze it in some separate text analyzer or something.
Right.
So, and we've talked, well, is it going to be able to improve your grammar or, whatever, your model of what's going on?
Yeah, where you go from it, I mean,
what are the limits?
Yeah, I mean, this is absolutely the beginning, but the idea, the nucleus of the idea, I think, is stellar, because before what we had was statistical stuff to kind of like throw text. I'll give you some old school ideas that we had. Oh, we'll just go and we'll throw it at a tagger. It's going to go through and use statistics to find, what the part of speech is. Oh, we'll use that. We can use that. The difference now is that we have the ability to get information it's almost a way to get structured information just using the language. And then when you get it back, I mean, again, it's language to language. You can ask the question. It's like having that human being sitting there and you can get the information. You may want to just build an analyzer. Look at this. You can build an analyzer in NLP++, whose job is going to go through and find the hierarchy of the human body by just, doing queries, getting it back in JSON, creating a knowledge base that's a KBB file in NLP++, and now you have something. One of the things is, I was talking, I don't remember, I think I was talking to one of the guy yesterday, because I was talking about this, and the next thing we knew, we were talking an hour about this. The problem with you say, draw a picture of a bunch of people at a birthday party and a woman blowing out her candles and her hands folded. You see their hands folded and it's got 16 fingers. There's a hand pulling out of her elbow, all those things. Why are those things happening? Because it doesn't have a knowledge of the human body in it. It has a neural network and transforms that got to a point where it can kind of generate things nicely and beautifully, but it doesn't have a model of the way fingers are to make sure, those things come up. That's the same analogy that you have in text or audio. So you have the problem of not being another one is, yes, you can look inside a large language model and find that it has separated animate from inanimate. What it's done is it's separated stuff, because when we talk in English specifically about animate and inanimate objects, patterns are there. those patterns with the transforms done in clever ways can kind of see that. The thing with NLP++, what we want to do, and I call it with a natural language understanding global initiative, which I'm getting more people involved. I wouldn't believe how many people are starting to get involved with that. Is that our goal is to build knowledge so you get it once. Right now, we're almost finishing up. We're almost ready to run on the Portuguese Wiktionary to generate all the words in Portuguese, which is one verb has 67 forms. 67. So to run has 67 forms. We don't have a dictionary anywhere. It doesn't exist anywhere. And so having that information is not going to change. That information of that's a verb and this is the root of it, those things don't change, but they're not even there. A hand on a human being, the ontologies of these things, we're kind of building them ourselves. We have them. We haven't had, and Amnon and I've talked about this forever, we haven't had a single place to put it. Where do we put it? It's now like the dictionary that we're building for Portuguese. They're going to go, oh, wait a minute, that's an NLP++. They start using NLP. Hey, this is the perfect thing to use it in. We have the framework into which to have this. So the idea of passing the fifth revolution and linguistically, which I wrote an article about, is we are passing linguistic and world knowledge to computers. And with large language models, that rule-based system can do a lot more on its own than it did before. So I would look at really more of the large language models as the memory or the knowledge of everything that we can make these rule systems build on itself more and more, so that when we have the ontology for the human body, it's one, and it's one place, it's in one format. Yeah, you can change it if you want, but that's the way I kind of see the whole picture.
Can I ask, I didn't fully understand it. So you go from the LLM query to the JSON and then to the KBB file.
Yeah, well, what happens is in large language models, depending on what you're talking about, you can ask for the output in different forms. And you can do two things. If you do it with English, of course, you can go and write an NLP++ to read it, right? But why do that? You can have an NLP++ function take in the JSON and directly put it into a KBB form or a dictionary form. And as Amnon said, and we have I think Amnon has the patent on that. We had early on automatic rule generation. Yeah,
I want to talk about that.
Yeah, go ahead. Why don't you? Yeah, well, I don't want to make sure you answer the question. So yeah,
go ahead.
The idea, Nina, is we've got the perfect platform and language to literally talk to, in an intelligent way, large language models. And yeah, that's it. And to me, that hit me. Yeah, go ahead.
Oh, and do you think I can also read back the KBB file into the LLM? Or is it just that I feed the KBB from the LLM and then we create this more not like concept-based system?
That's a darn good question. And the way I would, at the top of my head, I would say no, but I'm not certain, because those are basically kind of indexing they're really text vectors. That's where it all started. Once I understand that, I'm not, again, transforms and all that, that's a whole different ballgame, but they're still just kind of text vectors. So you're going to take these hierarchies and you're going to go with text vectors with them. I will be, if I were to take my best guess right now, the answer would be no.
So basically we would stick.
Well, I get
NLP++.
You're breaking up a little when you
go ahead.
speak.
Say that one more time.
So could I say we will make, using the knowledge graphs and knowledge base from NLP++, we would have a different level of intelligence of the system, because now we have concepts, but it's generated out of the now existing LLMs?
Well, yeah, there's a couple of things. One is that LLMs are statistics. So it's not like a human collection of what these concepts are. It's going to be a guess, right? What I see NLP++ doing is being the human, the language that gets us in this fifth generation of linguistics, which is to get these concepts into the computer. Here's, if I were a person out there, and I'm not a computer programmer, I'm imagining that, oh yeah, there's somewhere in the world there's a dictionary of Portuguese with all, all the verbs and all that stuff there, and yeah, computers know about that. They have to. It's arbitrary, right? But that's not true. So it could be the fact that I would give an analogy to the dictionary stuff. What I have talked with my two employees, young employees, who have been working very hard on the side with me on building the dictionary. We're getting it from Wiktionary. Wiktionary is a great place to see things and be able to get information. Well, what if we find that the words are bad in there? Whoever put them in, which is a voluntary thing. I said, yeah, Wiktionary is going to start thinking, well, we can generate it. So the question is we have that, do we generate then encyclopedias? For instance, we could have it so, I'm totally off the, I mean, I'm hallucinating right now. So it could be that, to answer your question, maybe
David is an LLM. We never realized.
Yeah, I'm hallucinating. But what we could do perhaps is to take those KBs and make it so that we do generative stuff from it. And that way we would know what the difference there. Like I said, I'm surfing on the edge of a wave I've never been on, but the way I would, just thinking off the top of my head, what that would do is that we are not relying anymore on a LLM to luck into the right hierarchy of the human body, for instance. If we have that, we could then generate from that the generation. And one of the things that LLMs are absolutely stellar at, I mean, something that if you're an NLP person blows my mind, they never are ungrammatical, ever. They have seen so much text, they will never generate a bad ungrammatical text. So what I would say that question would be is certain things. Yeah, if you want to generate a report about this stuff or talk about it or summarize it, what it's now doing, if we did it in the right way, and I don't know what that is, I think the indexing, what you'd have to do is take what I would call a formal knowledge-based system. How do you index that in a way so the hallucinations aren't there, but it can still use the language for it, right? Because it knows a lot about language and a lot about words.
Oh, I'm just asking also, the LLMs right now are the baby LLMs, right? Mm-hmm. This is the beginning of this technology. It's not old. Let's assume they want to create something intelligent, maybe to some degrees understanding what it's built of, right? And I would basically say if I have a ton of KDB files, for example, for a certain area, and then I would create a novel architecture out of NLP++ that can read these KBB files. It's a generator that knows the knowledge, right?
Mm-hmm. Yeah, it is. I think the whole thing about this, I think what's fascinating to me when this hit me like a ton of bricks, when I was talking with Roger Dev, I was literally going back with my head, I'm literally holding my head from exploding, is that all these questions can exist when you understand the rule-based, because I think what was happening before, we were kind of lost as to what these two things were and how they relate to each other. And now you are already, because this, even though it's new, asking really good questions, because what we have now is sort of like where Python is the language to script everything together, NLP++ can be the rule-based, knowledge-based, confident thing out there. And then how does this work? How do you have this? It's not just NLP++ using it to make more knowledge, but you're talking about, okay, you've got this stuff. How does that go back into that? I mean, I could see, could we get to a point where once we build the knowledge over here with NLP++ that is agreed upon, that's not it's not statistical, because you have to remember, every one of us, every human being that's ever lived has a different grammar in their head. It's called an idiolect. We in linguistics call that an idiolect, like idiot, idiolect. That means each person's grammar is different. There is no way we're going to have the same, but there are things that we agreed upon. The human race as a whole has created knowledge. These things are known. Words are known. Meanings of things in the world, how we've labeled them, are known. What a car is, all the parts of those things are. Because once we get them into a place that's a repository that we can hold on to as kind of like, these things are the truths of the ontologies and dictionaries we have. And yeah, we got to keep them up and change them and all that. Those then, if you put them back into large language models, now you don't have the problem of your training of large language models and its concept is a little bit different of the human body. It's got some weird thing that's wrong, you know. So yeah, I mean, you're already going with this kind of these two things together in your hands. You know, how do they work together? And like I said, it's so new that it's kind of like, you know, being in a kids in a candy store with all these candies you've never seen before. Because what do? How do you? It just makes you think a lot.
So I think, you know, speaking more generally, you know, we have these, we have a whole new perspective on how to build a cognitive architecture. You've got LLMs can bring in all kinds of world knowledge and nice language generation. Right. You know, from the NLP++ side, you've got rules, you've got knowledge hierarchies, and so on. And maybe a missing component in all this is what is the reasoning engine? What is the actual reasoning component of this architecture? But you know, it's all a voyage of discovery. I mean, yeah, you can say we'll use the LLM for this and that. Yeah, and how each feeds into the other. I mean, we don't know. We're just, as you say, it's totally new. So it's a voyage of discovery, right? It's the more you do this, the better the systems will be. They can evolve into something we have no idea about right now. I do want to talk about the automated rule generation that we did start even as far back as year 2000. So David had the idea, basically, of you have a hierarchy of stuff. Basically, you have an analyzer framework and you have a multi-pass analyzer framework. And the example was a resume analyzer. Okay, that's what we started with. So you build a framework, an NLP++ multi-pass framework for a resume analyzer. And what you need to flesh out that resume analyzer is samples from text from actual resumes. So David had the notion of a hierarchy kind of stubs. So for example, you'd have people's names as a stub, and you'd have education as a stub, and experience, you know, job experience as a stub. And you can go from the most atomic level of words all the way up to phrases and even sections of a resume. You know, you've got the experience section of a resume, you've got the education section of a resume, and so on. So this hierarchy, this kind of pre-built hierarchy of stubs is already present. And what David's idea was, you take an actual resume, you take a resume sample, you say, okay, I'm going to highlight a guy's name, and I'm going to say, and you know, basically we had an interface for doing this. You take the guy's name and you say, okay, that's going under the name stub, and you say, oh, here's an experience line or an experience sentence, I'm going to put it under the experience stub, and so on. So what happened, using this framework, this analyzer that already existed with all these stub areas, stub passes, the analyzer generated itself from the samples. So, you know, I think what you're talking about, David, is really along the lines of what we had with rule generation. You've got the LLM automatically filling these stubs, maybe finding samples out there, or you know, that looks related to what we already had.
Wow.
You know? So if you have the framework already there, LLM can fill those stubs.
Well, what you're doing.
Validate that and check it, and then.
I'm sorry?
How do you validate what's generated? and
Oh,
check it so it doesn't hallucinate when it creates those rules?
Oh, no,
Well,
no.
basically, go ahead, Dave.
Yeah, the rules are created by a function in NLP++. What it does is it goes through all the telephone numbers that have been, give a telephone number is an easy one, right? Area code, something, and bank, and so my dad knows all those things. Those are 3 sets, right? So you have lots of them with different, parentheses, dots, everything, right? But then what you do is you have all these things, and then you have a function that is a rule generating function that's just a hard-coded function that knows and looks at data and says, okay, these things, oh, I see this, and then I generate, oh, I'm seeing, okay, it's going to be this with it basically is a logical function that creates from the examples that an LLM, that now he's saying what you're doing is what we had users do, and they would go to lots of resumes. The idea is they go through lots of resumes, and we would keep all the things that they have categorized already, tagged, and then we would have
Highlighted
a function,
and categorized.
right? Then we have a function that goes through and creates the rules from it.
So it was more than that, because what happened was you would take a resume sample, you would highlight the pieces of it and say what they are. This is a name, this is a telephone number, this is a experience line, and the NLP++ engine would analyze those resumes, all those resumes, and build one pass at a time in context. In the context of each resume, it would build the pattern as it appeared in the parse tree at that stage of the parse. So this is actually a patent that we have. The one patent that was approved was this automated generation of text analyzers. It's out there. I think I'm the author because David couldn't be the author. I don't know.
No,
Somehow,
it was more the price, because just to add another person, it was just so expensive.
whatever it was. I mean, somehow you got knocked off by
I don't
the
care.
patent attorneys, whatever. I mean, your name is in there, but I was like,
It was my idea, but
it's your idea. I implemented the whole damn thing. So
Yeah.
Well, but yeah, that it was really neat, and we've never done anything with it since then, because
so the answer to your question, Amy, it's not going to generate something bad, because it's going to look at the patterns. What could happen is if you get outliers, you can kind of go in and say, what are the outliers? What are those kinds of things? And you can eliminate it, because if you see, what you end up doing is you let it generate, and you look at it, like a human will still look at it and say, oh yeah, this one's way off, throw it out, and then the rule system becomes less than, I mean, you could just have it generate a rule for every one of them. That would be kind of stupid, obviously. So,
well, if the samples are good, there's nothing wrong that's happening.
Exactly.
If you're creating bad samples, you'll get a bad analyzer. But if the samples are proper, if that's really a name, if that's really a school name or a job name, then then things will generate right.
Something I can also maybe add, I also didn't fully understand yet how it would always be correct generating it. I would assume it likely does not correctly generate it, and please go ahead and call me wrong. But what I did is, so I have a proposal written for DARPA that was about scientific claim checking. So anything that's a claim can be checked by another LLM, right? So you can create in between checks, and we did a mixture of experts on that one. So it's pretty good, actually, if it's an internal check-in.
Mm-hmm.
An architecture that checks itself, basically, based on.
Yeah, well, yeah, I mean, again, you've got a framework in this method anyway, where if the samples you're getting are good, if you take a resume and you say, oh, if you correctly say, well, that's the name of the school, then it's going to generate the right thing. But if the sample is bad, then you might generate something bad, certainly.
Depending on what you generate, it's not so easy to generate the correct.
Well, Well, yeah, the other thing is too, is if you don't have all the types of variations from it, right? You may not get everything, and then something else comes along. But then again, if you have that, again, with this kind of model, you should be able to, then you get a new what the large language models are doing is taking the place of the guy afterwards. So what you do is you build the intelligent program that's not only intelligent. What we have been building with NLP++ is mimicking human intelligence in a way that's traceable and mimics how people do it. And then afterwards, we've had to augment it and make it better ourselves, right? We have a team doing that. And the thing is now we could build, instead of just building the recognition of something, you also add into your NLP++ code things that where before we would just shoot things out that it didn't fit, and then a human would look at it. No, now what we would do is write NLP++ code that says, okay, if you have this problem, you can do all kinds of stuff. You can do another human reader on that, right? You can build another NLP+ digital reader whose job, kind of like the LLMs, make certain evidence to do something like summation, mathematics, those kinds of things. You could do the same thing with NLP++, and you say, okay, I'm going to go over here, write this guy. He's going to look at it and say, okay, go out and make this query to this kind of LLM. Get the information back. If you have the right information in the right way, oh, now I can go ahead and add that to KB, or I can add that to the dictionary. Then you can even rerun it if you want. You could, in what we're talking about further on, you're talking about you could have the analyzer itself. I mean, the intelligent, this whole thing about writing NLP++ writing itself is going to be more of writing an NLP++ agent in code that will do these things that will help build the analyzer that you're doing. So I guess it goes too far, then my mind just goes.
We have more information about this somewhere, like also the automatic rule generation.
There's a patent to it, isn't there? Amnon, you can look it up.
Yes, yeah, I'm looking it up right now.
Maybe you can send something around. That would be great. I can look it up.
I'm gonna send a link right now. Let's see.
So one of the things I'm imagining from all this is that in the hype, which has been, there's hype and there's super hype. This hype is I mean, it's a lot of interesting things, but just go try to register a domain with .ai. Domains cost usually between $13, $15, maybe up to $30 a year. AI domains right now, they're going for 150 and on up.
Yeah.
No. I mean, why? Hype. That's it. People want them. But I'm thinking what I was thinking to do is maybe to get a meeting where I can get as many of us together who is working on NLP++, with a bunch of people now, and talk about how we would integrate NLP++ with the large language models. How would that be done? And to augment the language. So, I don't know what the answer is really. Believe me, I can't, my brain's exploding already, but I mean, that would be kind of a meeting to kick off like, okay, what is the actual integration? And then if that integration really happens, we could actually test it out on the simplest one, which is the address parser for Brazil. Turns out though, a person in Europe, the talk I'm going to give on next week, a person had written a bottom-up island-driven regex address processor. And then she saw NLP++ during this 90 minutes, and she goes, I'm switching it all over to NLP++.
I sent a link, by the way.
Oh, okay.
Thank you.
But anyways, so that would be kind of an upshot here, going back to a rule-based system that you have the confidence in. And again, the thing I just thought of while talking to you guys, which would be not only the rule-based system's confidence, but it could be used and still used as an explanation with confidence. Meaning, yeah, I went out to this place and got the information back, and whatever that means. And if it goes wrong, where it went wrong and why. I think that's way different from, and that's an augmentation as well. I think the difference, now again, I'm just thinking absolutely at the top of my head, first time, but it's not that it's going in and making a decision to say you need your liver removed and it shouldn't be removed. What you're doing is you're augmenting a system that makes that decision that is confidence-based, which is NLP++ analyzer using, at that point where you have that. Well, the only thing what you would say is, oh yeah, this thing was added. It called this LLM. It was added at this point. That then was traceable. But still, that's not going to be any better or worse than a human being doing it. But it's not making the decision, right? And I think that to me is something I just thought of while I was blabbering today, which I do.
David, you're listed as an author and as an inventor along with me.
Oh, cool, man! I didn't even put that on my resume. I could have gotten another $5,000 a year on that one. Come on.
There you go.
I'm gonna have to drop off. I don't know if we're recording or not.
Yeah, we are.
Okay, well, you guys can keep going, or I can, or you can drop off. Thank you very much for all this.
Okay. All right. Thanks.
Yeah. See you guys.
Bye.
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 So I guess my next step, I mean, first of all, I wanted to get this to you, Nina, because when I was talking to Roger Dev, he's not an NLP person, he's pretty strictly an ML person, but he was really, I asked him, would you be interested in authoring a paper about this? And he goes, absolutely. He says, I'm terrible at writing. I said, well, don't worry. I have a guy who's very good at writing.
Oh, I want to be part of the paper too.
Absolutely.
If it comes to LLMs and NLP++.
Absolutely.
Get everybody on it.
No, I think, I think what would be great would be have two people from the ML side and two people from the NLP++ side writing this. And I think the
Nature.
picture, huh?
Nature now, please.
What do you mean that? Well, you're our whole contact you are so good
Reality.
Yeah. So what are you saying? Say what does that mean?
Oh, I just
Nature.
wanted to be highly published because then we get to know, see, Amy is so careful. This is a tiny workshop at a good conference. I was like,
Yeah, I know.
But now, please, let's try at least a big journal and see if they hate it or not. I think they like it.
No, I mean, one of the things is, and even Amy said that, she said that she thinks that the doctors' eyes will perk up when they see a system that's justifiable, right? I think that's one of the things that they're worried about. And I think the thing that I kind of came up with today, Nina, that I think is really good. This would make the LLM people really happy, because what we can do then is we can put it into critical systems with still the ability to trace back in a way that's not, the harm is off to the side by making the knowledge or the adjustment to the rule-based system could have some flaw because of that. It's not a direct contributor, right? And I think that is very interesting. I think that's very interesting. Okay, so you're interested in it. So you're the expert. What do we need to, is there like a template for overleaf that we can use for
I can
this?
create one.
Okay, and then you invite it. And then what I need to do is I will get Roger Dev's email and have him included as well.
You can maybe connect us as well.
Absolutely.
Let's create a meeting where we meet.
Yeah, absolutely.
Overleaf out. Hey, David, for the LLC, by the way, I found a name for my AI, and the name .ai is $130 because all these people bought it. I guess it's a business.
Oh yeah, absolutely it is. Yeah. I mean, I looked up stupid. I'm an idiot. I like NLP.ai. It says make an offer.
How much?
Yeah. Oh, I'm sure it's tens of thousands, if not more.
What
about
about
NLPPP?
No, that actually one of them is taken. It may be PPP is not taken, but it's $150. Yeah. So NLPP plus would be NLP plus.
Stop recording. I tell you my name for the company.
Oh, okay. Okay. All right. I'll stop recording. Hold on. That's